Hello everyone, welcome back to our channel Acadecia. So far we have completed matrices and determinants. So let's move on to a new topic called rank of a matrix. So what do you mean by rank? Coming to the definition of rank is nothing but the maximum number of orders of a non-singular square submatrices. So the definition is quite weird, no? So instead of definition, if we understand through an example, it will be quite simpler for you. Suppose let's take a matrix like this. Suppose if they are given a matrix called A like this, and for this we have to define what will be the rank of this matrix. Rank of a matrix is denoted by like this, rank of a matrix called a given matrix A. Okay, now how we will define the rank of this matrix? The rank may be, it can be 3 or 2 or 1. Okay, the rank of a given matrix, it can be 3 or 2 or 1. So how can we define whether a given matrix has a rank of 3 or 2 or 1? So let's move on to the properties of that, such that we will understand. Suppose for this given matrix A, if for this given matrix A the rank is 3, for the given matrix A, if the rank is 3, then this matrix should be non-singular. That's the condition. Rank of this matrix, rank of A matrix, if it is 3. What do you mean by the rank of a matrix A? If it is 3, then the det of this A must not be equal to 0. That means this matrix should be non-singular. Suppose if this rank of A is equal to 2, then the det of A should be 0. That means it should be singular. But the submatrices which are there, those must be non-singular. Okay, and if this rank of matrix is 1, that means the det of A should be 0. That means the matrix should be singular, and then the submatrices also should be singular. So, if you remember these properties or not, no matter. Suppose if they are given a matrix A like this, first do this det. If that det is not equal to 0 in the first step only, then it will be 3. The rank will be 3. Okay. And now, if we take this det again, if it is 0, by this whole det is 0, but individual submatrices are there. Submatrices in the sense like this. You can take this as a submatrix, you can take this as a submatrix, and you can take this as a submatrix. So these are all submatrices. Instead of a matrix, if you take the submatrices det, if those det is not equal to 0, then the rank will be 2. Okay. And if you take the entire matrix, again it is 0. And what all the submatrices you are taking, if those also the det is 0, then the rank will be 1. So from the properties what we have learned and the rank and the properties is, rank is nothing but we have to identify what all the maximum number of orders of a square submatrices will be 0. It's like nothing but if we are given a matrix like A, first we have to find out the det. If for the first attempt only the entire matrix det is not equal to 0, then simply we can mention that the rank is 3. And then if we take the matrix A, if the det is equal to 0, and then if you check on the submatrices, if it is not equal to 0, then the rank will be 2. And if the entire matrix is 0, the det is 0, and then the submatrices also, if the det is equal to 0, then the rank will be 1. Okay. Now let us take an example such that we will understand. So randomly I am taking one example like if this is a matrix A that is given for us. Okay. In order to find the rank of this given matrix, first thing you have to find the det. How we are going to find the det? You have to multiply the submatrices to that adjoint element which you are taking. Now it will be 1 into minus 8. 8 into minus 1 minus 8 minus of minus 2 into 3 it's minus 6. Okay, minus 2 into, if we remove this it will be 0 into minus of minus 1 it will be minus 1, and then minus 2 into 7 it will be minus of minus 14 plus 3. 3 into, if we remove this and this it will be 0. Sorry, it's a 0. 0 minus, it's minus 2 into minus 6 of minus 14. Okay, it will be like, it is minus of minus, it will be plus. Okay, then it will be minus 2, and then minus 2 into minus plus, it will be minus 14, and then it will be plus 3 into minus of minus 14, it will be plus 14. So simply if you see like this, it will be minus 2 times of 14 plus 3 times of 14, and then it is completely not is equal to 0. So from this, we can identify this rank is 3. Simply if you find this det if it is not equal to 0, then we can conclude that rank is equal to 3. Suppose, for suppose if you take this matrix, if we are getting the det is equal to 0. Now, what's the next is, you have to take a minor like this. Okay, a sub minor. This also we can take. Okay, as a minor, if you are taking now 8 minus 2, 3 minus 1. If you are taking this, and for this you have to find the det. It will be minus 8 minus of minus 6. It will be minus 8 plus 6. It is minus 2. It's not equal to 0. If this complete det of A matrix is 0 and the submatrix is not equal to 0, then the rank will be 2. Okay. If this submatrix det is also equal to 0, instead of minus 2 if it is 0, then the rank will be 1. Okay. So, through this example, what we have learned is how to find the rank. If they are given a matrix A like this, first find the det. If it is not equal to 0 directly for the entire matrix A, then the rank will be 3. Or else if it is 0 for suppose, and then take the submatrices like this. Any submatrix you can take. Okay, 2 into 2 submatrix, anything you can take. And for that, if it is not equal to 0, then the rank will be 2. Or else, for the submatrices also the det is equal to 0, then the rank will be 1. So for a given matrix like this of any order, you can find like this. So moving on to the next topic, characteristic equation of a matrix. Okay, suppose if you are given a matrix like this. Suppose this matrix is given. For this matrix, how we can write a characteristic equation? It will be like lambda 3 minus s1 lambda square plus s2 lambda minus s3 is equal to 0. This will be the characteristic equation. So, in this, what do you mean by s1, s2, s3? s1 is nothing but the trace of the principal diagonal. Trace of the diagonal is nothing but we have to add these principal diagonal elements. Then S11 will be A11 plus A22 plus A33. If we add these three, whatever the sum we will get, that is considered as S1 and that should be multiplied with lambda square. Okay, and then what will be the S2? S2 will be the sum of the minors. Okay, this will be the minor of A11. Okay, and these two will be the minor of A12. And these will be the minor of A13. So we have to add those minors. Then that will be the S2 value that we have to multiply with lambda. And now coming to the S3, it's simply the det. we have to find this debt of this given matrix A, and that debt is simply known as S3. So, like this, we have to substitute S1, S2, S3 values in this characteristic equation. So, from this, if any matrix is they give, through this equation, we can write a characteristic equation of this. Now, let's check on few standard results regarding the rank. Suppose if you are given a matrix A, now rank of A will be is equal to rank of A transpose also. Suppose if you find the rank of A, if it is 3, then the A transpose rank also will be equal to 3. Okay. And then if the rank of A is given, that will also be equal to rank of transpose conjugate of a matrix also. We have learned about this A transpose and conjugate transpose of a matrix in our previous videos. Rank of A, if it is a non-singular matrix is nothing but the debt will not be equal to 0. If this rank is not equal to 0 and if this matrix is of order n, okay, order n, then maybe 3 or 2 or 1, any order. If that rank of A, whether A is non-singular of order n, then the rank will be of this matrix will be n only. That means nothing but the order of that matrix. Okay. On to the next topic, echelon form of a matrix. So, by the way, what do you mean by echelon form? Suppose if I explain the definition, it will be quite weird, like rank of a matrix as well. So, in order to explain this echelon form, better if we take an example, it will be easy. Suppose here also if it is 0. So, imagine this is a matrix given for you. And now the echelon form is nothing but, you can see these zeros, these are increasing. It means the echelon form is nothing but the number of non-zero rows, those will be the number of non-zero rows which are present over here. If they are increasing than the number of zeros rows. Okay. These are the non-zero rows. In this, nothing is a 0 over here. These are 0 rows. All are zeros. Suppose if these 0 rows, these are 0 rows and these are non-zero rows. If the 0 rows are greater than this non-zero rows, then that will be the echelon form of a matrix. That means these zeros will be increasing on. That will be known as a echelon form of a matrix. So, moving on to the next topic, here we have to learn about this consistent and inconsistent systems. So, what do you mean by a consistent system? Suppose if they are given a matrix A, for that, whether if it is a consistent or non-consistent, we can differentiate between those two by the means of solutions. For a consistent system, if the solution will be one or more than one solution is present, then it will be known as a consistent system. If no solution doesn't exist for that, then it will be inconsistent system. Okay. Regarding these systems of solutions, the solutions of systems for 3 unknowns. If there are 3 unknowns in that system, then in order to find this, whether it is a unique solution or infinite number of solutions or no solution, we are going to verify these conditions. Suppose if I given a matrix A like this. A matrix A is given. Immediately, if you want to find the rank or if you want to find the consistency of that system, what we have to do, the immediate step is to find out its debt. Suppose, if they are given a matrix A, you don't know how to find these all consistency, inconsistency and how to find the rank and all that. Simply find the debt. You will get whether it is 0 or 3 or negative values or something. You can get in these values. Not only 3, it's maybe a natural number. Okay, if regarding this debt, we can identify. Suppose the debt is directly not equal to 0, then you will get only one solution, that will be known as unique solution. Okay, if this debt is equal to 0, then there will be a condition, two conditions. Whether it can be infinite number of solutions or it can be no solution. Regarding these two, again we have to do these steps as well. So first you have to find whether it is consistent or inconsistent. Check on whether it may have one or more solutions, or else if the solution doesn't exist. After that, you have to go through this. If the given matrix, the debt is equal to 0 or not equal to 0, we have to categorize. If it is not equal to 0, simply we can state it has an unique solution. The problem is over. If not, if the debt is equal to 0, then what comes next? There will be two options. That will be infinite number of solutions or no solutions. Regarding these two, only one should be the answer. Okay. Regarding these two, we have to follow these steps as well. Okay. Suppose if we have a matrix A, B, two matrices. For that A, B matrices, the rank of A is not equal to the rank of A, B. Then there will be no solution. Okay, suppose if you are given a matrix A, you have find this rank as 3. And you have given A and B two matrices individually, they are given. Now we have to find the product AB. For this rank we have to find. If this is also 3, sorry, if it is 2, suppose. Directly we can say rank of A and rank of AB doesn't equal. Then there will be no solution. Suppose if rank of A is equal to rank of B, if both are 3, okay, then there will be unique solution. But the condition is if these ranks, those are equal to the number of unknowns. Okay, if this is less than the number of unknowns, there will be infinite number of solutions. So like this, we have to categorize the whole flow chart. So first, what all the properties we have to remember is, if a matrix like A or AB when they are given, first find out their debt. After finding the debt, you will get a clarity whether it is equal to 0 or not equal to 0. If it is not equal to 0, directly you can write the unique solution, then the problem will complete. If it is equal to 0, then there will be two more chances. Regarding these two more chances, we can conclude these all properties. Okay. So now moving on to the next topic. Suppose the rank of A is equal to the number of variables, then this will be known as a trivial solution. Then we have 0 solutions. And if the rank of A is less than the number of variables, then it will be non-trivial solution. Then it have infinite number of solutions. Now, what do you mean by these variables? Suppose, look at this. These two are the equations and here these are the variables. A1, A2 and B1, B2, these are all the variables. Suppose through this, if they given the equations like this, we have to form the matrices like this. First, we have to write these individual variables over here in a single matrix. After that, what all the constants which are there, that we have to write in a single matrix. After that, these solutions we have to write in another matrix. Like this, we have to form the matrices if they are given equations like this. Okay, through this, if we have to find whether it is a unique solution or infinite number of solutions, what we have to do? Just simply, these variables which are there, just simply divide A1 by A2 and B1 by B2. If these both results are not equal, you can define it as a single solution. Or else if this A1 by A2 is equal to B1 by B2, then it will be infinite number of solutions. Okay. Through this, you can identify whether how many number of solutions or which category of system of solutions does it belong. Okay. So today in this video we have covered rank and then echelon form of a matrix and then characteristic equation, how we have to write the characteristic equation for a matrix, and then we have seen in order to find out the rank of a matrix, what type of solutions there will be, unique solution, infinite number of solutions, no solution, and what type of system does the matrix belong. So all these few properties we have learned in this today's video. So I hope you would like this video, and if you have any doubts, please let me know in the comment section. And then if you like the video, please like, share and comment and subscribe to our channel. Thank you.